Assalamualaikum and good morning, everyone. So, we are from Group 5, and today we will present our project 2 for BDG35303 Wastewater Treatment. So, our project is entitled Wastewater Treatment Design Proposal. In this presentation, I will explain the background of our project the treatment process, the function of each stage, the project finding, and the conclusion. For our team, before we begin, these are our group members who will contribute to this project. First is Muhammad Shafiq Wan bin Muhammad Awi, Muhammad Zikri Fazil Ali, and Muhammad Azman bin Muhammad Afiq.
So next, I will continue for introduction. This project focus on designing and constructing a laboratory-scale wastewater treatment model. The model simulates wastewater generated from a biodiesel and oleochemical processing plant. The treatment system consists of 6 main stages, which are the wastewater reservoir, equalization and screening, pH adjustment, aeration, filtration, and finally the treated water basin. Instead of using pumps, the system operates entirely by gravity flow. This makes the design simpler, more economical, and suitable for laboratory demonstration. The main objective of this project is to demonstrate the basic principle of industrial wastewater treatment and show how water quality can be improved through several treatment processes. So the next slide shows the completed physical model of our wastewater treatment system. The model was constructed using transparent containers connected by pipelines, allowing wastewater to flow naturally from one treatment stage to the next. Each compartment represents a different treatment process. This arrangement makes it easier to observe how the wastewater change throughout the treatment process. So before treatment, wastewater from biodiesel industries usually contains suspended solids, oil and grease, organic matter, color, unpleasant odor, and unsuitable pH level. These pollutants can harm aquatic life and the environment if discharged without proper treatment. Therefore, an effective treatment process is necessary to reduce these contaminants before the water is released. The next slide is the illustration of overall treatment process. The wastewater first enters the reservoir before flowing into the equalization and screening tank. Next, the wastewater undergoes pH adjustment to neutralize its acidity. After that, the aeration stage increases, dissolves oxygen, and supports further treatment. The wastewater then passes through the filtration media to remove remaining impurities. Finally, the treated water is collected in the last basin for inspection.
So, for the treatment stage, this slide is summarize the 6 treatment stage used in our system. Each stage has a different uh, function, and together they improve the quality of the wastewater before it reach the final collection basin. In the next slide, the other guys will explain the function of each stage in more detail. Thank you.
Description of each treatment stage. Stage 1 is the wastewater reservoir. This stage stores the raw wastewater and provide gravity flow throughout the system. Stage 2 is equalization and screening. At this stage, large suspended solids are removed while the wastewater flow become more stable before entering the next treatment process. Stage 3 is pH adjustment. Here, the wastewater pH is adjusted to around pH 5 to 6, creating a safer condition for following treatment stage. Stage 4 is aeration. Air is introduced into the wastewater to increase dissolved oxygen and reduce unpleasant odors. Stage 5 is filtration. Our filtration media remove fine suspended particle, reduce color and remove dissolved impurities, producing cleaner water. Finally, stage 6 is the treated water basin. This stage collect the treated water so that its final condition can be observed. And next is project finding. Based on our project, several important findings were obtained. First, the gravity flow system operated successfully without requiring any pump. Second, the screening stage effectively removed large suspended particles. Third, the pH adjustment stage reduced the wastewater pH to approximately 5 to 6. In addition, aeration improved oxygen transfer, while the filtration stage produced noticeably clearer water. Overall, the combination of these treatment stage successfully improved the quality of the wastewater. In conclusion, we successfully designed and constructed a 6-stage wastewater treatment model. This project demonstrated how physical and chemical treatment processes work together to improve wastewater quality. Although this is only a laboratory scale model, it successfully represents the basic principle used in industrial wastewater treatment system. This project also highlights the importance of proper wastewater treatment in protecting the environment and supporting sustainable industrial practice. Thank you.